In this video, we will go over some examples of simplifying expressions using the quotient rule. So example A, we can think of that problem as 15 times itself 8 times, divided by 15 times itself 3 times. So if we think in terms of how many pairs of 15s, numerator and denominator, can we match and cancel, we can match and cancel 3 pairs, and that would leave us with 5 15s in the top of our fraction. Or we could use the quotient rule, which says take the top exponent and subtract the bottom exponent. And so here we have 15 to the 5th power. For example B, I can do example B one of 2 ways. I could use the quotient rule, the top exponent minus the bottom exponent, and get y to the 13th, or I could think about the definition of a negative exponent and move the y to the negative 9th up to the top of the fraction. So then I would have y to the 4th times y to the positive 9, and I would take advantage of the rule that says add the exponents. Either case, you're going to have y to the 13th power. For example C, I have 35r to the 6th power over 25r to the negative 4th. So I need to simplify the coefficients, 35 over 25, and I need to simplify the r's. The 35 over 25, since both numbers are divisible by 5, I'll do that and get 7 over 5. And here we're taking advantage of the quotient rule that says take the top exponent and subtract the bottom exponent. Now, I could also think of r to the negative 4 in the bottom as needing to be moved to the top, in which case I would have r to the 6th times r to the positive 4th, which would also give me r to the 10th. For example D, I have 34 over 51 that I need to simplify. I have a to the 8th power over a to the 12th power that I need to simplify, and I have b to the 11th power over b to the 5th power that I need to simplify. So 34 over 51, 17 goes into both 34 and 51, so I'll divide those both by 17. If I think in terms of matching and canceling, I have 8 pairs of A that I can match and cancel, and I'll be left with 4 A's in the bottom. I could also do 8 minus 12 and get a to the negative 4. And then my b values, I have b to the 11th power over b to the 5th power, so I have 5 pairs of b's that I can match and cancel. Or again, I can use the quotient rule. So what we end up with here, if I use the quotient rule, I have 2/3 a to the negative 4 b to the 6th. Typically, we don't leave answers with negative exponents, so we want to move the a to the negative 4th. We want to take the reciprocal of that. So our final answer, 2b to the 6th power over 3a to the 4th power. Here we have some terms that are all being multiplied together. I have 5x to the 3rd. Then in parentheses, 2 to the negative 1x to the 4th raised to the negative 3rd power. So what do we do? Well, PEMDAS, parentheses, exponents, multiplication, division, addition. So we want to get rid of the x or the parentheses first, and we'll do that by using the product rule for exponents, which says I'm going to take this negative 3 times the negative 1, and I'll take the negative 3 times the 4th. Often we think of this as distributing this exponent, but the term distribution doesn't really apply the way it's meant to. So now we have 5x to the 3rd power times 2 to the positive 3, x to the negative 12. So what I need to do next is combine my coefficients, 5 and 2 to the 3rd power, combine this x to the 3rd with this x to the negative 12. Now the rule for my exponents on the x's tells me to add these. So I have 3 plus a negative 12. 2 to the 3rd is 8. So I'm eventually going to multiply the 5 and the 8 together. X to the negative 9, we want to make sure that 9 is in the denominator of our fraction. Similar goings on here. I need to simplify 30 over 45, r to the fourth over r to the negative sixth, and s to the negative ninth over s to the third. 15 goes into both 30 and 45. I'll use the quotient rule. 4 minus a negative 6. I'll use the quotient rule here, negative 9 minus 3. So I end up with 2/3 times r to the 10th s to the negative 12th. Don't leave negative exponents in your answer. So finally we end up with 2r to the 10th, 3s to the 12th. Here we have a little bit more complicated expression. So we're going to start off by getting rid of these parentheses. This negative 2 exponent applies to both the 4 as well as the b cubed. This negative 3 exponent here applies to both the 4 as well as the b to the negative 1. And this negative 4 exponent applies to 4 to the negative 1 as well as b to the third power. And that's what we see here. Now we have a whole bunch of negative exponents that we need to do something with. But first, we're going to combine like terms. So our rules for exponents says when the bases are the same, we'll add these exponents together. So negative 2 plus a negative 3, b to the negative 6 plus 3. And on the bottom, we didn't do anything with that. So now we have 4 to the negative 5, b to the negative third, over 4 to the fourth, b to the negative 12. Now we will worry about combining like terms, top and bottom. So we'll use the rules of exponents that say take the top exponent and subtract the bottom exponent. So 4 to the negative 9 and b to the positive 9. Don't leave negative exponents in your answer. And we have b to the ninth power over 4 to the ninth power.